So I'd like to talk a little bit today about how we can use the remainder theorem and the rational root theorem together to find all the roots, both real and imaginary, of some polynomial function. So when I say find all roots, I'm looking for the real roots, which would be the same thing as a 0 or an x-intercept, but then any imaginary roots as well, which wouldn't show up on a graph, but you get it when you solve for when the function is equal to 0. So we want to start by thinking about what the possible rational roots would be. The rational root theorem says if you're going to have a rational root, here's a list of what they would be. So that's all the factors of all the factors of q, which would be plus or minus 1, plus or minus 5, that's your last number, divided by all the factors of p, which is your first number, which in our case is just 1. So for us, for this problem, the possible roots are just 1 over 1 gets us 1, and 5 over 1 gets us 5. So we have we have 4 possible rational roots, plus or minus 1, plus or minus 5. So we can use the remainder theorem to test. So say we wanted to test x equals negative 1. I could plug in and see if I get 0. If I plug in and I get a y value of 0, that means my point is on the x-axis, and it's an x-intercept or a real root. So negative 1 cubed plus 3 times negative 1 squared plus negative 1 minus 5. And I can evaluate that. Let's say I get negative 1 plus 3 is 2, minus 1 is 1, minus 5 is negative 4. However, if I didn't want to plug in and say it was a number harder than negative 1, I could also do synthetic division. So if I plug in negative 1 for synthetic division, the remainder that I get should also be negative 4. That's what the remainder theorem said. That's 1. That's negative 1. So this is positive 1, so that's negative 4. And your remainder is the same thing as what you get when you plug in. So basically what I've told myself twice is that negative 1 is not a real root. So we have to test something else. Let's test positive 1. Now again, I could plug in or I could use synthetic division. Now I'm just going to use synthetic division because the result that you get is also useful. So if I plug in, or if I use synthetic division for 1, 3, 1, negative 5, I get 0 as a remainder. So x equals 1 is a real root of f of x. So again, the reason why I like to do synthetic division is because the numbers that you get as an answer are actually helpful as well. What you've basically said is that f of x is x minus 1. That's the factor for x equals 1. And then what you have left over is x squared plus 4x plus 5. These numbers are the a, b, and c values of a quadratic. So if I know that f of x factors to this, then if I want to get any more solutions, I can set x squared plus 4x plus 5 equal to 0, and I can solve that. If you look for a second, you'll probably realize factoring is not going to work here. So I'm just going to do the quadratic formula. X equals negative b plus or minus b squared, which would be 16, minus 4 times a times c, all over 2 times a. So if you simplify that, you're getting negative 4 plus or minus root negative 4 over 2, which is negative 4 plus or minus 2i over 2. So I get 2 imaginary roots, and I get 1 real root. And that's it.